All right, one more region. So now we know that all sp2 carbons are more de-shielded than sp3 carbon. So both sp2 carbon show up downfield on region 3 and 4. Okay, that's an orbital effect. But the last region is the sp2 carbon with electronegative atoms. Okay, so that's add more inductive effect. So this type of carbon show up really downfield on the left side of the spectrum. Okay, so 150 or higher. All right, so would like you to draw a line at 200 ppm. Okay, once you have this line, so here's what happened. The carbonyl carbon now is an sp2 carbon with two electronegative atoms. Okay, so this carbon, we got acid, ester, amide, have chemical shift less than 200 ppm. So it could be 160, 170, 180, 190, around here. So less than 200 ppm. Only aldehyde and ketone show up over 200 ppm. Okay, acid, ester, amide, less than 200 ppm, and then aldehyde, ketone. Only these two functional groups, really distinct on carbon NMR, show up downfield, even further downfield, over 200 ppm. Okay. All right, let's use it. So get the hang of it. This diacid compounds looks like they have 4 carbons, but this guy have symmetry. Okay, only two carbon, 2 signal appear on here. If I draw the line just to help our eyes, now you can see obviously. So A, that's carboxylic acid, so below 200, so about 180 ppm. That's gonna be an A. All right, and the B, that's just an alpha carbon, right? CH2, so should show up on region number 1, right there. Okay. All right, one more. Next practice. Okay, so same thing, 4 carbon, but they got symmetry. So A and B, you got only two different carbons, so 2 types of carbons. So we have A and B. All right, look at the spectrum. I'm drawing the line, 1, 2, and 3. There we go, 4 regions. Okay, obviously, so A and acid right there, and B is an sp2 carbon of alkene, so appear on region number 3, A and B. There we go. All right. Before we go right here, so I would like to point out, so from these two spectra, okay, these are similar acid, right? So we there's from the red A and the blue A. These are carboxylic acid, right? Carbon of carboxylic acid should have the same chemical shift, but the one down here is more shielded. Okay, it's more shielded, and the only reason this happened is because it got resonance with the double bond. Okay, make the chemical shift go lower. If you still remember IR 1715, like usually carbonyl carbon, right? When you add a resonance into it, it shifts lower than 1715. Similar to that. Okay. All right, that's it. Let's move on to the next one. So these are the whole chemical shifts chart you should have. I customized it for just this class. Right? You can look up the chemical shift chart of carbon NMR in anywhere. Just Google it. Click on the images. You will see it. Right? But this one, it just I customized it, so make it like fit in our class. Okay? But anything works. All right.